Hello everyone. Today we'll discuss one of the stack question and which is basically asked in different product companies interviews. And so we'll just go through the question, understand the requirement and come with the possible solutions and try to implement them. So the question is we have to design a stack which will support features like push, pop, getting the top element, retrieving the minimum element with the constraint that you have to support all these operations in constant time. So that is a catch of the question. So you have to support all these operation in constant time. So if you know, basically stack is last in first out data structure. So we know that the push pop and getting the top element is already in the constant time. So we have to implement this getMin function in such a way that we are able to get the minimum element in the constant time. So I recommend you all to pause the video for like 5 minutes and think about the possible solutions and then resume the video. Now let's deep dive into the problem and let's think of the possible solutions. So one thing which comes into your mind is why not maintain a minimum variable uh, which is global to the stack, and whenever you are pushing anything into the stack, just see that if the value which you are pushing into a stack is lesser than the minimum value. If it is lesser than the minimum value, just change the value of that variable, else just push it into the stack. And if you want to get the minimum value at any point of time, just return the value of that minimum variable. So let's see how it works, whether it works or not. So let's say I'm pushing 2, my stack becomes 2. The minimum value is 2 because there is nothing in the stack now. So minimum value is whatever you post. Now let's say I push 8. Now the stack will become 2 8 and the minimum value will be still 2 because 8 is greater than 2. Now if I push 20, my stack will be 2 at 20. Minimum value will again be 2 because 20 is greater than 20. 20 is greater than 2. Now, if I push 1, my stack will look something like 2, 8, 21. My minimum value would be 1 because 1 is less than 2. So looks fine from here up to here, because if I want to get the minimum value of the stack, I'll just return the minimum variable, which is like 2 in this case, 2 in this case, 2 up to here, 1 up to here. So I'm getting the minimum value of this whole stack in constant time. But the problem occurs when you pop the element, which is minimum. Let's say I pop one element from the stack. My stack looks something to like this, to 820. Now my minimum value is 1. So if I call the function get minimum, it will return me the 1, which is incorrect because 1 is no longer in the stack. So here comes the problem that when you're popping the element, if it is a minimum element, you have to change the minimum variable by traversing the whole stack, which is not in constant time. So in that case, a pop function will not be in constant time. So we have to think of some alternate solution because isn't working. So what I can think of one more solution is, why don't we maintain a node? Node will contain value and the minimum value. The value will value means, which is the value of the node. Minimum variable means that it is the minimum value up to that point of the stack. So whenever we have to get the minimum value, we'll just get the minimum value of the node which is present at the top of the stack. So at any point of the time, I have my minimum value to be will be the element which is the minimum value of the topmost node of the stack. So let's take an example from here. So let's say I push 2, my node value will contains two things here. Uh, so it would be value would be 2 and so value would be 2 and minimum value would be 2 because nothing's there in the stack and stack values are 2. Now if I push 8, the node value would be 8, the minimum value would be 2, the stack will look something like this to 8. If I push 20, the value of the node would be 20. The minimum value of the node is 2 because up to that point of the stack, the minimum value is 2. Now if I push 1, the minimum value of the value of the node is first of all 1. The minimum value would become 1. How it is 1? It will see the minimum value of the topmost node. The topmost node is 20. The minimum value of that topmost node is 2. Now we are inserting 1, which is lesser than the 2. So the minimum value will become 1. Now if I pop the element, my stack will be something like this. But if I want to get the minimum value, it would be the minimum value of this node. Now minimum value of this node is 2. So our answer is correct because up to this point, the minimum value in the stack is 2. So this looks a bit confusing, but if you see the implementation, you will understand how simple the solution is. So let's go into the implementation. I've already implemented the solution. So to save some time in this video, so let's go through the implementation and you'll understand how it is implemented. So this is my class in stack, which will have the inner class, which is a node basically, which will have two variables, value and minimum. Now my stack class has four functions: push, pop, top, and get minimum. Now my pop is fairly simple one. If the stack is not empty, I just pop the last element. The top is particularly the same. The getMin is if the stack is not empty from the last node, the stack.peek function return the last node, and I'll return the minimum value of that node. So the crux of the whole solution is in the push function. So whenever I am pushing some value in the node, I'll create a new node. I'll assign the value as whatever I am passing. The minimum value is, if the stack is empty, it would be the same value, else it would be the minimum value of the current value we inserted and the minimum value of the topmost node. So if the current value which we are inserting into the stack is less than the minimum value of the topmost node present in the stack, the current minimum value will become the value which we are inserting into the node now that we push into the stack. So this is basically the solution of the problem we are implementing. We have implemented all the four operations in the constant time, and we started with a different solution and we came to the right solution. So that's how you have to approach in the interview. You have to think out loud. You have to come with some sort of solution which is solving at least some cases. You'll get some hints from the interviewer. You will correct your solution and you will implement this. So hope you like the video and please subscribe my YouTube channel Code York and share this video as much as possible. So thank you.